In today's lesson, we are going to continue to look at expanding binomials. And in particular, we're going to look at what our results are. So what is that final form or that last line or expression that we get when we expand them? So what we're going to do first is we're going to expand these and simplify these four expressions. You can choose to use either the FOIL method or the box method. I'm going to do one in each. But again, if you have a preference, by all means, you are more than welcome to do them all in the same way. So the first one I'm going to do as FOIL method. However, before I can even use FOIL method, I have to distribute or multiply this 2 through. Right, remember, we talked about in the last lesson, when we're multiplying multiple things together, multiply the first two, get your answer, and then multiply that product or answer with the next bracket or term. So I'm going to multiply the 2 through. 2 times x is 2x. 2 times negative 3 is negative 6. And then that answer is going to multiply x plus 6. Let's move this down. Again, the FOIL method, first, outside, inside, last. So when I go through and multiply, 2x times x is 2x squared. 2x times 6 is plus 12x, negative 6 times x is negative 6x, and negative 6 times positive 6 is negative 36. We should recognize again, same thing as before, our two middle numbers tend to be our like terms, so we add them together, 2x squared plus 6x minus 36. And again, this is our simplified form at the end. For B, I'm going to use the box method. But again, before I can use the box method, I have to multiply this negative 3 through. So what I get then is negative 3x minus 6 times x plus 4. Now I have two brackets. So I can set my two brackets up onto either side of my box. So negative 3x, negative 6, x, and 4. And then multiply through the corresponding columns and rows. So x times negative 3x is negative 3x squared. X times negative 6 is negative 6x. Negative 12x, negative 24. Again, we should see that these two brackets, or these two boxes, are like terms. So when I simplify this, negative 3x squared minus 18x minus 24 is my final expression. X plus 3 squared minus 1. So this looks a little different, and this is going to be a little different from our previous steps. But we should recognize that x plus 3 squared just means x plus 3 times x plus 3. And then I have the minus 1 at the end. So I can FOIL or expand the two brackets, and then at the end, when I'm collecting my like terms, then I can throw in that negative 1. So x times x is x squared, x times 3 is 3x, 3 times x is 3x, 3 times 3 is 9, and then I'm going to throw in the minus 1 at the end. This is going to be a little different. I still have my two like terms in the middle. However, now I have also two like terms at the end that I can combine. So I get x squared plus 6x plus 8. And again, that's my final expression. D is again a little bit more confusing. I am going to use the box method for this one, but before I can do that, I have to do some things first. So this can be rewritten as negative 2 times x minus 1 in brackets times x minus 1 in brackets, and then minus 11. We saw before with that minus 11 that all we have to do is just add that in when I'm collecting my like terms. But first, in order to use the box method, I have to get two brackets, so I have to multiply this negative 2 through to the first bracket. So I get negative 2x plus 2 is my first bracket, x minus 1 is my second, and minus 11 gets thrown in at the end. What I'm going to do, I'm going to put one bracket at the top, so negative 2x and 2, x and negative 1, and I'm going to worry about that negative 11 later. So now what happens, again, same thing with our box method, multiply our corresponding columns and rows. So negative 2x squared, 2x, 2x, and negative 2. Again, I see some like terms here, the two diagonal rows. So if I rewrite this, I have negative 2x squared plus 4x minus 2, but this negative 11 has to come in still at the end. I'm not forgetting it. So minus 11, and I should recognize that I still have two like terms, so I can do the two numbers at the end. So negative 2x squared plus 4x minus 13. So looking at these two or these four expressions, is there anything we recognize? And you may not notice it at first, but what we should eventually see is that in my first term, or my first two, a and b, those expressions that I multiplied or expanded were basically our factored form of a quadratic. And in c and d, they were essentially our vertex form of a quadratic. And by expanding both of them, we get something that looks to have the same form or a similar form. And what we actually did is that all of these expressions represent a quadratic in what we call standard form. So all these expressions that we came up with by expanding, these are all standard form expressions. And we can get to standard form expressions by expanding our factored form or by expanding our vertex form. So this is our third representation of a quadratic that we could have. So the standard form of the quadratic is an equation that's written as y equals a x squared plus bx plus c. Again, a, b, and c are just going to be variables or letters that that represent values. In the standard form, those values will be filled in with a coefficient or a number. The only two pieces of information that this equation or form gives us is one, the a value, which again, same as the vertex form, same as the factored form. The a value tells us the direction of the opening as well as the step pattern. So that a value, or that first number, that first thing that should be multiplying x squared or the bracket, that is always going to represent the same thing. A, direction of the opening or the step pattern. And the other new thing that this equation gives us is our y-intercept. And that's just the last value, that constant, that c value, or whatever value only has just a number. No variable attached, just a number. That is our y-intercept, and it tells us where the parabola crosses the y-axis. So this form really isn't used too much because it doesn't really give us any information to help us graph it, but it tends to be just a standard, straightforward one. It's the simplified version, as you can see, because we expanded and simplified the other ones, so this is just our standard form. So what we want to do in our next two examples is just practice again the same thing we did, going from one form to another. So in the first example, I'm given vertex form. We can see here, I'm given the vertex form of a quadratic. I want to know the vertex, the step pattern, and the y-intercept. So my vertex, again, we should get from our h and our k value. So if you don't quite remember that, please go back and look at the lesson on vertex form. but our vertex is h and k. We see our h and k from our general form. If we don't remember the form, again, please review that. But again, remember for our h value, we take the opposite of what we see, so positive 4. And the k value, we just take it as is. So in this case, 8. The steps, remember the steps we get from that a value or the number in front. Again, remember the steps follow the pattern 1a, 3a, 5a. So in this case, 1 times 3 is 3. 3 times 3 is 9. 5 times 3 is 15. Now we need to get our y-intercept. There's an algebraic way we can do it because we know that the y-intercept is basically a point with the x value of 0 and a c value or a value for y, so we could plug in 0 for x and solve, or we can expand this and see what the last value is. We're going to go through and expand it just because that does give us our other form as well. So if I want to expand this again, remember 3x minus 4 squared just means x minus 4 times x minus 4. Then we have the plus 8. We want to multiply the 3 through first. So we get y equals 3x minus 12 times x minus 4 plus 8. Now we have to expand our binomials using FOIL or box method. Again, whichever you prefer. I'll do this one again as a box method. So if I draw my box out, I have my two brackets. So 3x minus 12, x minus 4. Inside the box, I'm multiplying my corresponding rows and columns. 3x squared, negative 12x, negative 12x, and negative or positive 48. I see that my two diagonals are my like terms. So if I rewrite this, or if I simplify this, I get y equals 3x squared minus 24x plus 48, and then this 8 carries down, so plus 8. I can see that I have two like terms, those constants, y equals 3x squared minus 24x plus 56. Let me just move this over. So I have my equation in standard form. That c value right at the end is my y-intercept. So I have a y-intercept, you could say, of 56, or you could give the actual point, which is 0, 56. And that's your y-intercept. So basically it just gives you some more information. You could think of it as like a starting value, or where x equals 0, again, depending on what scenario you're looking at. In the second example, again, the same thing, except now we're looking at the factored form. And in the factored form, we can convert this into a bunch of different equations and find a lot of information. It actually lets us find the most information. So if we want to find the vertex, we have practiced with this before, so if you don't quite remember, go back to our factored form note. But with the vertex, remember, we can find the x value by adding up our two x-intercepts and dividing by 2. So in this case, it might actually be helpful to find our x-intercepts, which are just our two values in the brackets opposite of what we see. So our x-intercepts are 3 and negative 5. So if I want to find the x value of my vertex, or again that axis of symmetry, that middle value, I add those two x-intercepts up. So 3 plus negative 5 and divide by 2. So in this case I get negative 2 over 2, or negative 1. So this is actually my h value. So I know my vertex is going to be at negative 1 and something. I figure the second part out by subbing the h value into my equation for x. So y equals 4, negative 1 minus 3 times negative 1 plus 5. Get 4 multiplied by negative 4 times positive 4. I have negative 16, and then negative 16 times 4 is negative 64. So that means my k value, or the y value of my vertex, is negative 64. So I know the vertex for this equation, or this parabola, is going to be negative 1, negative 64. The steps, again, I get from the a value, follows that pattern, 1a, 3a, 5a. So 1 times 4 is 4, 3 times 4 is 12, 5 times 4 is 20. So there's our step pattern. Same thing that we've done before. If I want to find the y-intercept now, I am basically going to expand this and find the c value. So y equals 4, x minus 3, x plus 5. I'm going to use the FOIL method here. Again, remember, first thing we have to do, because we have that 4 out front, I need to multiply that through to my first bracket only. So 4 times x is 4x, 4 times negative 3 is negative 12. Then I have x plus 5. I'm going to use my FOIL method in this one. So first outside, inside last. You can choose to use box method if you prefer. This one's a little bit simpler because we don't have to add or subtract anything after. So 4x times x is 4x squared. 4x times 5 is positive 20x. Negative 12 times x is negative 12x. And negative 12 times 5 gives us negative 60. I can see I have two like terms in the middle, similar to what I've found before. I'm going to go through and simplify it. 4x squared plus 8x minus 60. This is my standard form, and I can see that my c value is right here at the bottom. So my c value, my y-intercept, is negative 60, or you could say negative 60 and 0, the point specifically. So again, this is just taking a look at expanding and our vertex form and factored form, similar to what we've done in the past. A little bit added difference here because with vertex form, we do have that little constant that we have to add at the end. But this is just showing that when we do expand those two forms, we get our standard form, which does give us some more information about our quadratic, as well as we looked in the example, or the second example, with our factored form, and we saw how we can go from factored form to find the vertex and then to find the standard form or the y-intercept. So it just shows how all the forms are basically connected, and they all give us some different information. And we'll look at kind of the overall summary of them all and how they kind of all can change between each other in our next lesson.